Alrighty, here we are at number 6. Here's we're going to do a little bit of polynomial division, okay? Let's use our polynomial long division here. It says select the expression that is equivalent to all this stuff right here. Okay, just real quickly, let me mention, why do you guys think they put this here? X cannot be -3 or 0? How about 0? What if x was 0? What you get is 0 squared, which is 0, plus 3 times 0 is 0. We can never divide by 0, okay? That's why x cannot be 0 on this one. And how about that -3? What happens if we plugged in -3? -3 squared plus 3 times -3. I'm plugging the -3 in for x to see what happens to this denominator. -3 times -3 is positive 9. Positive 3 times -3 is -9. So what we got here is 9 minus 9 equals 0. We never divide by 0. We can't divide by 0. It's undefined at that point. So the only reason I'm going over that is because it's going to help you on some of these other questions here. Okay, let's go on with this long division. It's going to look just like this on your test. You're going to take that numerator, that's what we're dividing, 2x cubed plus 11x squared minus 21x. Okay, we're going to divide this by that denominator, x squared plus 3x. All right, here we go. I need something. I got to multiply something times x squared to make it look like 2x cubed. So I need an x. X times x squared would be x cubed. And I need a 2. So I'm going to write that right over here. I'm going to put it over the x squareds. 2x squared times, or no. I don't need 2x squared. I just need 2x. So what I'm going to do is move it over a little bit. Let's put it over here. All right, now, here's what we wanted. We wanted that so we could multiply it times this so we could get 2x cubed. So let's do it. 2x times x squared is 2x cubed. That's going to cancel out that 2x cubed just like we like. All right, what are we doing now? We got to multiply the 2x times the 3x. So 2 times 3 is 6. X times x is x squared. What I've got here is plus 6x squared. And now, what do we always do in long division? Whether it's polynomials or just regular good old-fashioned numbers, we subtract all this junk, all right? 2x cubed minus 2x cubed is 0. That cancels out. 11x squared minus 6x squared. I'm thinking what we're looking at here is 5x squared. We bring down this good old negative 21x minus 21x. And looks like I need a little more space up here. Okay, so what's the goal now? We're trying to make this x squared. I need to figure out something that I can multiply times x squared to make it 5x squared. And that's just 5. So plus 5. So now we got that. We're going to multiply times the x squared and write our answer right down here. So that is 5x squared. And now I got to multiply this 5 times the other thing. Okay, right? We put the numbers up here just because we want to multiply it times the first number, but we ended up having to multiply it times both of them, right? Here. And then times here. And then this one we multiplied it times that one, and we got this right there. And then we multiplied it times the other one. So 5 times 3x is positive 15x. Wow. Okay. It's a big number. This is going to be interesting. We're subtracting all this stuff. Alrighty, the 5x squareds cancel out. I've got negative 21x. And do not forget, this minus is getting distributed over here. Minus 15x. So we're going to get some big negative number down here. Negative 36x. And here, we're kind of done with the division. Because look, I can't get x squared out of a 36. Negative 36x. This is to the power 1. This is squared. We're done here. This is a remainder. Okay? So what we got to do is rewrite this. Let's rewrite it as we got the 2x plus 5. Here's our answer. And already I can tell there's only two possibilities. It's got to be either A or D. Now, let's add the remainder. Okay, we got a negative 36x. So it's actually going to be minus 36x divided by, it's still stuck over top of that x squared plus 3x. Okay, why do we do silly stuff like this? This shows me what the end behavior of the graph is going to do. As x gets really, really big, this thing is going to be approaching the same end behavior as 2x plus 5. And as x gets really, really big, this fraction is going to get super tiny small, get closer and closer to 0, and be completely meaningless as these x's down here get larger and larger. Now, I got one little problem here, right? We got 2x plus 5 up here, 6 over x plus 3. And then we got 2x plus 5, 36 over x plus 3. It doesn't quite look like, this looks pretty close to this, but it's not exactly. Is there something we could do to simplify this a little bit? Look, I've got this common factor of x here, and x there. If I divide everything by x, we could simplify this a little bit. So we got 2x plus 5. And I'm going to pull an x out of the numerator and the denominator. Minus 36. I divided 36x by x. I got 36. I'm going to divide x squared by x and get x. And 3x divided by x is 3. This looks like it could be one of the answers, right? That looks like D. Here we go. And that's what we're going to do. Do your longhand division. Figure out when you can stop dividing. Whenever your remainder is smaller, has a smaller degree than your leading term up here. And then rewrite it over top of this denominator. We couldn't get it out from on top of that denominator right there. So it's stuck. This 36x squared is stuck up there. But we were able to pull all this other stuff out.